Good morning. So now I am going to explain the study of losses and numerical aperture in optical fiber experiment. So for doing that, first we will be making the setup. So in this board, first we are connecting the sine wave to the analog buffer block using this cable, using this wire. Then from the output of the analog buffer, we are connecting it to the transmission in TX in. So then, so this is the TX1 output. So we are connecting using the optical fiber cable to the RX1 receiver end. So from the receiver end, so we are connecting using the wire RX1 out to the AC amplifier block, and the output of the amplifier, the amplified output, we are connecting it to the using the BNC cable to the oscilloscope. So the input signal we will be getting from here, the sine wave, positive and the ground. So first, while starting the experiment, ensure that the frequency and the amplitude is in 2 volt and 2 kilohertz. Adjust that by adjusting this now, frequency and amplitude. And after getting that, we will be getting a sine wave. Now turn off the input and enable the output readings using this. And for getting the output, first make sure the intensity knob is in maximum position and adjust the amplification little bit in such that we would be getting a sine wave. So after getting the sine wave, click measure. While taking the output, make sure the wire is straight and there is no bend in the wire, and the frequency will be constant. So take only the amplitude, that is 14.4 volt, and take a note of it. So that is the output amplitude, and the time period is in this case it's 500, almost 500 microseconds. Now remove this fiber optic cable and repeat the same for the 3 meter cable. We have found the propagation loss of the 1 meter and the 3 meter cable by measuring the output amplitude and the time period. Now we are going to do the experiment of bending loss. So for bending loss, we are going to use only the 1 meter cable, and how we are going to do is like we are going to make a bend in the cable in such that the diameter we are going to vary, like we are going to vary for 6 centimeter and 4 centimeter. So first we are going to take a scale. After making the bend, measure that and ensure that the diameter is 6 centimeter. For the 6 centimeter bend, so the amplitude will be getting reduced. So first it was 14, now it's 12, and again reduce the diameter for 4 centimeter. So now we are taking 4 centimeter, and again the amplitude will be getting reduced. So now it's 9 volts, and again when reducing the diameter, again the voltage will be getting reduced. So that is the bending loss experiment. Thank you. We are going to do numerical aperture experiment. Connect the optical fiber, the 1 meter cable, to the TX2 and turn on the switch. So that will enable the LED, and we will be getting the visible light here. So this is the zig, and connect the cable inside the hole. And now we are going to use a scale to measure how far it is from here. So we are going to take 3 readings: 0.5 centimeter distance, 1 centimeter distance, and 1.5. So we are going to keep the wire in the 0.5 centimeter distance, and we are going to take the vertical diameter and the horizontal diameter, and take a note of those readings. The vertical diameter is MR, that is 1 centimeter, and the horizontal diameter is PN, that is 0.75 centimeter. Again vary the distance from the bottom for 1 centimeter and 1.5 centimeter, and again do the same, taking the vertical diameter and the horizontal diameter, and take a note of those readings. So this is the numerical aperture of the optical fiber. Thank you.